in Hamburg in Germany, a lot of container ships going in and out all the time. And there was one guy calculating that one ship going in and out is producing more CO2 emissions than all vehicles in the whole city, including trucks and everything, in 1 year.
Greetings, Earthlings, and welcome back to your podcast, the show where we power your passion for making the energy transition a reality. On today's show, we're going to clear out the hype and get to the straight talk about one technology that is central to enabling the hydrogen economy, fuel cells. They are the linchpin in converting hydrogen into energy. And when you think about it, a kilogram of hydrogen contains more than twice the energy per kilogram of gasoline, diesel, or natural gas. So when you think about it that way, you can see why experts have been eager to see the hydrogen economy gain some momentum. But before we beam off on today's away mission, I'm your host, Lisa Ann Pinkerton. I'm the CEO of Technica Communications and the founder of Women in Clean Tech and Sustainability. And if our show has opened up new doors of knowledge for you and provided valuable insights or just simply enriched your day, I ask you to please consider leaving us a rating or a review on Apple Podcasts. Your feedback not only supports us and our work, but also helps others discover our content. So please take a moment now to leave us a few stars. Don't worry. This podcast will be waiting for you when you get back. Additionally, for those of you who are passionate about staying on the forefront of societal change through education and informative content, we invite you to join our Patreon community. We're currently crafting the exclusive Earthlings Club, which I guess, when you think about it, we're already a part of anyway. But this is going to be a special club where members can gain access to perks and features and special content available only to our Patreon members. And here's a little incentive. Remember that t-shirt design I talked about a few episodes ago? Well, it is in development. It's coming soon to a Patreon page near you. So we will send 10 Patreon members a complimentary t-shirt. So you have all the incentive in the world to join our community. Now, some of us have been waiting for the hydrogen economy to gain traction for a long time. I was an NPR environmental science reporter for 12 years in the, I guess we'll call them the 20-aughts, into the 2010s, and now doing PR for 15 more years. So a long time for myself, and I'm sure a lot of other people. Even if you only first heard about the hydrogen economy when the governor, Arnold Schwarzenegger, promised California a hydrogen highway, 2004 is still a long time to be waiting around for this industry to get off the ground. And especially when you think about the hydrogen fuel cell was invented 50 years before the first marketable automobile. And, if you think about it, petrol, gasoline, diesel, that entire economy has had 150 years to work out its kinks. And hydrogen is still getting its feet under it, if I can mix metaphors. It was invented in 1839, hydrogen fuel cells. And then, just the technology sort of continued to be refined over the years. NASA used hydrogen fuel cells in its Apollo missions. It showed a great promise in decarbonizing heavy industry and heavy-duty transport, which is why we're talking about it today. And the guest we have for our show is someone who is bringing his automotive perspective to the fuel cell industry. His name is Philipp Ruez, and he's the head of sales for industrial applications at EKPO Fuel Cell Technologies. We caught up with him from his office in Metzingen, Germany, just south of Stuttgart.
Well, fuel cells actually have a very fantastic technology. So actually, it doesn't produce any emissions besides water and electricity, which is what you want to have. And it consumes hydrogen and air, which is endlessly available, basically. So Yeah, it is probably the only way to produce energy and store it for a longer period of time in an eco-friendly way.
Especially with significantly less weight compared to perhaps some lithium-ion battery chemistries, I would think.
Yeah, probably. I mean, I think it depends on the application. If you're talking about passenger vehicles, then for sure the weight should be okay with batteries. So I think you can have a small car powered with batteries. But I think if it comes to heavy duty applications and stuff where you need to move heavy weights over long distances and stuff like that, no matter if it's trucks or ships or trains or whatever, I think then it makes sense to change from diesel to fuel cells and hydrogen.
You manufacture the fuel cells, and I just want to make sure everybody's on the same page. So could you explain to us the basic principles on how a fuel cell works? We understand that it uses hydrogen and it transforms that hydrogen into energy, but it's not magic, right? So what are the steps involved?
So it's basically an anode and a cathode side. So it's similar a little bit to batteries, but it uses the hydrogen on the anode side and the oxygen on the cathode side, separated by a membrane. And what happens is that the hydrogen is split up into the protons and electrons, and the protons go through the membrane, the electrons go around, generating the energy. And on the other side, the protons react with the oxygen, making the water and leaving the fuel cell as water vapor or liquid water. Simple words. We have specialists doing nothing but taking care of the chemistry on the MEA and inside the MEA. So they could have a separate talk for hours with you on that.
And what makes your designs of a fuel cell stand out amongst others that are out there?
Yes, right. So we have been developing fuel cells globally, from a global perspective, for 20 years now. So we've been working with many different customers. I think this experience really helped a lot with the products that we have invented lately and being ready for the market right now. So what we see and what the feedback is from our customers is that the power density is probably the highest on the market, with the 6.2 kilowatt per liter. And the efficiency is also quite high. So what we get as a feedback, the customers are very happy with it. Durability, quality in general is a very, very important topic for us as well, which is basically why we have set up a very industrial production process. So that the whole stacking of the bipolar plates and the entire cell row is being done fully automated. So that gives us a really high quality level.
And then are yours modular? They stackable, right? Is that different from other types of fuel cells?
You can use multiple fuel cell stacks. So the stack is basically what we're producing. And you can use multiple stacks in series or in parallel, just depending on what the voltage level is that you need for your application. But of course, then still you need the balance of plant components, which are around the fuel cell stack. And that's, for example, a humidifier, compressor, etc.
How big is your standard fuel cell?
We have stacks reaching from 16 kilowatt, which is the smallest, up to 205 right now. So 205 kilowatt is the biggest one we have, the M12 Twin. But we are currently developing entirely new cell platform and a new stack, which will be in the range of 400 kilowatt per stack. So
That's a lot.
yeah, if you look into those heavy duty applications that we're discussing, the big mining trucks or ships or trains, all these applications are really looking for these. It's also more efficient if you have one stack that you need to connect into a system or that you need to build into a system. It's more efficient than if you have to build 20 stacks into a system, because you need to do all the wiring, all the hoses, everything, has to be supplied, all the air, all the oxygen, everything. So it just makes life easier for the integrators and for the end customers as well.
So those are you said 400 kilowatts or something around there?
Yeah, exactly.
So that is pretty big. And so I can assume that you're thinking about utilizing that for, like you said, trains, marine transport. I would think those are very heavy vessels. When you look at these different applications, where are you seeing interest?
I think we have met on the on the Replus show in Vegas. So it was a big show for stationary and power generation. So we see a lot of interest from that side coming. Apparently, a lot of even going up to the big power plants. Those companies are talking to us. But as you mentioned, of course, we have big marine projects ongoing. We have a lot of interest coming from the construction machinery business, like mining trucks or heavy excavators and stuff like that. And of course, the traditional business where we used to come from in the automotive industry. So that we're talking about the trucks, the buses, all of those applications.
In the industry, we talk about hard to abate sectors being like heavy industry and these types of things. I wonder if a better term would be like hard to electrify. And so we're going to go use hydrogen for that instead of your traditional batteries, simply because of the weight and power density issues and the long distances that some of these vessels need to travel.
Yeah, right. And actually, the funny thing is that a lot of the discussions ongoing are always black and white. So you can only use hydrogen or fuel cells and only batteries. But it's actually not accurate, because most of the applications still use some small batteries for recovering the energy while braking, or peak shaving if you need an extra going uphill or whatever. Yeah, I think it's using the right technology for the right applications, and combining those, the best of both worlds, right?
I think you're right, because there is like if you look at aviation, you need a big boost of energy to get the plane off the ground, right? And there's battery is a better use of that moment for a hydrogen plane than using hydrogen. But once you get up there, it's all hydrogen and no battery is needed, right? So there's this acceleration moment where a battery is very useful. And you're right, it doesn't have to be one or the other. I think people think they get these blinders on around one thing, hydrogen or batteries. So what kind of applications do you think we should prioritize? Because we could use hydrogen fuel cells for a wide variety of applications. And it sounds like there's interest across the board. But from your perspective, if we think about, the best way to usher in this energy transition, what are the applications you think society should be prioritizing for fuel cells?
I think if the choice is given to the society, then I think we should prioritize everything. So we should just get rid of combustion engines as fast as we can. But I think that the companies still want to, have a world that, but from a technological perspective, and also from the feedback that we get from our customers, I feel that the energy sector is pushing a lot, which I wouldn't have expected a few years ago, and the marine sector as well. So there is a big push from their end. And yeah, funny enough, it's not only about technological or economical reasons, but a lot of this push comes also from the political side. Legal restrictions pushing the companies to decarbonize. So if we look into the Marines, for example, what's happening there is that companies running the cruise ships are not allowed to enter fjords, I think, from 2026 in Norway anymore. So globally, it's not a huge country, right, with the biggest impact in economies or whatever. So even such a comparably small country can push the entire economy to change the mindset. I think, and there are quite a lot of cities with ports or harbors doing the same thing right now. So everybody's really pushing the companies to decarbonize.
Yeah, absolutely. I mean, you see these big cruise ships come in, and that smokestack is just black and billowing all the time. And you look at that thing, you're like, oh my goodness.
Yeah, you don't want to live anywhere near that. So I've read one figure which was impressive. It was that in Hamburg, in Germany, there is a huge container harbor that, a lot of container ships going in and out all the time. And there was one guy calculating that one ship going in and out is producing more CO2 emissions than all vehicles in the whole city, including trucks and everything, in 1 year. So that is just
Wow.
crazy.
And also too, like when you think about these big shipping vessels, they're using bunker fuel, which is some of the dirtiest fuel. And we ship a tremendous amount of fuel everywhere. So I think if we can start decarbonizing or, electrifying, if you will, these big marine vessels, I think it's going to make a huge impact on the air quality and the emissions of these various regions around the world.
Yeah, so I think that is going to be a big impact already. So decarbonizing the marine sector is already a big part of the cake, I guess.
And you're actually working with a cruise ship company to supply them with some fuel cells. And I'm sure you can't tell us who that is, but can you give us some idea of what you're working on and what the vision is for that ship that you're contributing to?
Yeah, very briefly, it's a cruise ship, as you mentioned already, and they're using propulsion system which is made out of fuel cells in the megawatt scale. So we're looking at something in the range of 5 to 15 megawatt. The basic idea is to build a prototype for such a cruise ship and to really run it on hydrogen. The idea is right now to have this first prototype running in and out of the fjords, in and out of the harbors, and hopefully also running on the higher seas with hydrogen in the long term. So that is definitely the goal.
So obviously marine transport really high on my radar, if you will, for decarbonization. We haven't even mentioned like industrial applications like steel manufacturing. There's some work being done using hydrogen. What other sort of industrial applications are you seeing that where we might be able to use fuel cells?
The major difference here is that for the steel production or aluminum production, you need a lot of the energy, but in terms of heat, what they do usually is they use the hydrogen to burn it to generate the heat and use that heat to melt the steel or the ore or whatever. I'm not an expert for that, but what's happening in the same time is actually they use hydrogen also to run the business and to run the companies. And that's something where I see a lot of potential for the fuel cells, because if the hydrogen is already there because they need it for producing the steel actually, then they could use the hydrogen also for running the rest of the business, all the appliances and computers and heating the building and whatever. So there is a lot of additional benefits coming of that technology.
So you're in Europe, and I'm curious to understand from your perspective where you're living, what's going on with the hydrogen economy there? What are you seeing? What's developing, especially around the generation of this hydrogen? We typically use this rainbow to describe all these different types, gray, blue, green. What's happening in Europe in terms of hydrogen production?
The problem we have in Europe is that we don't have too much sun and wind. Well, we do have some, but I think it's not really enough to power all of Europe. So what we see a lot ongoing is a lot of discussions with the southern countries, so the south of Europe, but also the north of Africa, where there will be a lot of power available coming from the sun, from the wind, and that will be transferred into hydrogen and transported up to Europe. So that's not a secret. I think we are building a pipeline across Europe from the south of Spain up to the north. I'm not sure if it's ending in Germany or going even up to the Baltic countries. And I think it's called the European backbone. And then we have pipelines coming from, I think it's Morocco, some of the northern countries, ending up in Italy. So there are a lot of projects ongoing, and there are some projects called IPSAI. I think it's important projects of common European interest. So there is one big project with a €1 billion funding just for hydrogen projects, basically. So yeah, there are quite a lot of things ongoing. And in the meantime, if you would have a hydrogen car, you could even run across Germany without any big issues because there are already 100 refueling stations all across the country. So yeah, there are quite a lot of things ongoing in Europe in general. But I think you have some nice projects in the US upcoming, right? With
Yes.
Inflation Reduction Act and those hydrogen hubs. I think it's 7 hubs across the US. So
Exactly. I feel like what you're doing over in Europe though is a little bit further along than what we have going on here in the US.
maybe we started a little bit earlier, but yeah, there's still time to catch up, right?
Yes, of course. I mean, specifically green hydrogen, I think is something that everybody is really watching. And in the United States, well, all the hydrogen hubs are great, and those are going to be green hydrogen, so we're definitely looking forward to that. But I get a sense from some folks in the hydrogen industry, especially here in the US, when I've been to some hydrogen conferences and such, they'll say, yeah, green hydrogen, it's great, but it's not going to take off for a while. And and we're not going to do blue hydrogen unless everybody's required to capture their CO2 emissions. So, just live with the fact that it's going to be gray. And I'm like, okay, great, thanks. Not really what I want to hear here, but so that's what I hear in the United States. Now, granted, most of the hydrogen in the US is made in Texas, so there's a certain perspective that comes along with that state politically. But I'm curious to hear from you from the European side of things. Is there a similar attitude of we're not going to capture our emissions unless everybody's required to do it?
I'm not an expert for that actually, but what we get from the discussions is that everybody's pushing a lot for green hydrogen. I mean, there will be a lot of gray, violet, whatever hydrogen around, and especially coming from the chemicals industry or all of those waste products that we use today as well for testing our stacks and our customers running the stacks, which is okay, I guess, because it's there already and it will be there anyway. So yeah, we can use it. It's not good, but that's what it is. So, but I think it will be just a very tiny portion of the hydrogen that we will need in the future. So investing now into anything else but green hydrogen doesn't make sense from my perspective. Oil industry or even some from the car industry might have a different point of view there. But as mentioned in the beginning of our discussion here, if you have two small kids and you want them to have a nice planet left over from our generation, I think we should definitely start now.
Absolutely. And if you think about green hydrogen, once these plants are up and running, the resource is free. And so the cost, the economics to make hydrogen, from solar, from renewable energy in a green way, becomes incredibly attractive. And it seems to me that it's just going to blow everything else out of the water.
Yeah, and I think that's what a lot of people are afraid of, actually, because if you've invested a lot of money into the oil industry, for example, you might lose a lot of money, actually, and it's the same thing with other industries that are depending a little bit. But I think the chances are much bigger than what you can lose. So the whole hydrogen industry and the whole, everything which comes with it, the fuel cells and everything, has so many chances to develop and to move on and to be successful that we shouldn't be afraid of it. We should actually push for it and embrace it because it's such a great technology, which is eco-friendly and it's there. And we don't even need any rare material, at least for the stacks, I can tell you, there's nothing in which is crazily rare or, yes, we have platinum inside, which is kind of expensive, but it's there already. So it's available.
Obviously, this is a futurology podcast, so I always like to ask this question, like, what do you see in the future, like 10, 20 years out for hydrogen fuel cells? What can we expect based on your experience?
Well, I forgot my crystal ball today, but I'm pretty sure that my personal opinion is that I think in 20 years from now, we will not see a lot of combustion engine applications anymore. The social pressure and the pressure from the legislations will be so high that in 10 years from now, probably not so many people will even invest into vehicles or ships or trains or whatever. And especially ships and trains have a very long lifetime. So let's say a cruise ship, for example, and it's running probably for 30, 40, 50 years. And if you buy that now, today, you can be sure that by the end of this life, it will not be allowed to enter any harbor on this planet with a diesel engine. So what everybody's pushing for, and you see that if all the announcements come in for new cruise ships, all of them are running on LNG because gas is already much more eco-friendly, low emissions, etc. And I think in 5 to 10 years from now, you will only see ships running on hydrogen. And even for retrofitting, there will be a huge market, actually.
When you're feeling anxious about why we aren't moving faster to adopt zero-emission technologies like hydrogen, remind yourself of this conversation and how Philip has reminded us that heavy-duty vehicles and vessels have very long lifespans. They were basically designed to run for 40 years or more, you know? And so it's understandable that some of these vessels and trucks and buses have been slow to adopt new technologies. And as these older vehicles reach their end of life, we still want to encourage these fleets to replace them with cleaner versions. And for many of them, that will be hydrogen power using fuel cells, which will make a lot of sense, especially if the cost of that hydrogen fuel is cheaper than gasoline or diesel and has lower emissions. I mean, that becomes a no-brainer for these fleets. Some who have very small margins, which is why we want to see more green hydrogen production alongside the adoption of fuel cell technologies. And that's definitely something we're going to explore in later episodes in this series. So I really appreciate that Philip has set us up with a really good foundation around the hydrogen economy so that we can explore it in more detail in future episodes. Stay tuned and let us know if there's any aspects of the hydrogen economy you would like us to explore. Our Faith in Humanity is restored this week by David Millark. He's the founder of the Ancient Tree Archive, which is a project focused on cloning the world's oldest trees to combat climate change. So, get this. His aim is to reforest the earth with trees that are resistant to warming temperatures and wildfire. And if you think about those two categories, ancient trees have the best genetics for this. So he has cloned 130 species, including sequoias, redwoods, 1,000-year-old oak from Ireland. And from his point of view, these ancient trees have the capacity to sequester 10 times more CO2 than the average tree just because of their sheer size and the fact that they live extremely long times. I mean, think about the Methuselah tree. That is 4,855 years old. It was well established by the time the Egyptians were at their height. I mean, sometimes mind-boggling sometimes how old some of these trees can grow. And if you think about the General Sherman sequoia, which is known to be the largest tree on Earth by volume, it has been found to sequester as much carbon as 86 years of emissions from the average American. Wow. Mind blown for me. So I think David is really onto something here. And I love that he's cloning these ancient trees and also building a living library of the genetics from these trees. And I hope it gives you some inspiration to discover how you could contribute in your own way to this beautiful blue-green space flower that we call home.